Greetings. This is the continuation of our Linux tutorial. In this case, we'll be actually starting to use the target VM, which essentially is a headless command line driven interface server. So there's no GUI. In this case, we're going to log in with the provided credentials for your course. And what we'll do is explore some of the commands that could be really helpful as a part of investigation, system collection information, general type of system administration, or perhaps some intrusion validation. So what we're going to do, the first thing is review the screen command. So the screen command is actually an intricate application. So what it does, in a nutshell, is the ability to create nested windows. So with a command line interface system like this one, as you noticed, we have only one window. So we can only do one thing at a time. The screen command gives us the opportunity to basically multitask. So the way this screen can be used is actually multi-purpose. So what can happen is we can provide, again, level of auditing for what a particular user is doing and get a transcript of the output that was displayed within the terminal. We can have multiple windows. For example, you SSH into a server. And once you SSH, I mean, you can't really do anything else from that server that you used to SSH, from, because you only have one screen. With the screen command, you can have multiple ones. So you execute the screen command, you create a new screen, and then you can have different tasks running with these screens. And you have a way through the screen interface, through this management interface, to basically go back and forth. In other words, is kind of a virtual KVM switch that you can multitask. The benefits of using screen are not just from auditing perspective. It actually keeps the shell, the screen, running even if there is a network interruption. So basically it allows you to connect and disconnect and reconnect even if you have a network interruption. Not that you're going to be able to communicate with the host, but the screen itself is going to stay on without interrupting what you were doing, or like where you left off, I should say. The communication, yes, it will be interrupted. The screen is not going to protect you against that. However, the task that you had, the information that you had, will not be affected. It will still be on the screen. So this capability to detach and attach screens can be really, really helpful. You have to leverage your creativity for the different purposes and usages. So the biggest thing that we're going to demonstrate here is the multitasking perspective. An attacker can use this to run tasks in the background. You can use it to multitask, manage multiple processes, perhaps doing a scan in one, watching a file in a different one, and so on. So let's get started. We use the help menu. We're going to get out of it. We are simply going to execute the screen command. So now we enter a new screen. It tells us the version of it. Great. So now we're inside the screen. Okay, we're going to type in screen again. So we're essentially starting a screen within a screen. Yes, it sounds crazy, but it's possible. I'm going to demonstrate this actually. Okay, so now we're within the second screen. So to identify how many screens we've created, we're going to use the screen command and then our favorite list. So in this case, it's only showing the one. There is one current screen in this session. Now, what we're going to do is we're going to leverage the keyboard on your computer. What we will do is, let's take a look. So you're going to hold down the Control A. You're going to actually not going to hold down. You're going to press Control A and then 0. Control A 0. Control A 1. Control A 0. So this is really Windows 0. Okay, so Control A1, it takes us to the first one. Control A 0 to the second one. You have to kind of press them quickly. So Control A, you press Control A, pressing, I should say, release. So I have to describe how I'm doing it. It's kind of hard. So Control A 0, Control A 0 is kind of like a sequence. Okay, Control A, quickly press and release 0. Now we're at this screen 0 and it shows us at the bottom. Control A 1, and it goes back to the first one. It's you have to practice on the keyboard. It's really kind of a very quick press and release type of movement. And then Control A is initiated each time, then use 0 and 1 to move between the screens. So 0 is the first window that we created, 1 is the second, 2, third, 3, fourth, and so on. Something else we can do is we use the previous and next. So Control A, N goes next, Control A, and then separately you press P, previous. Okay? So again, if you quickly press Control A, release, and then you press P, we go into the previous screen. You quickly press Control A. I just finished pressing it and released. Now I'm gonna separately press on N. We go into the next one. So Control A is essentially triggering the command, and then what follows after Control A is how the screen application behaves. If you press N, goes into the next window. P goes for the previous one. It takes a little bit time, but it can be really, really helpful once you leverage it. And this will be not much of a use in the graphical user interface because you have the workspace area, if you remember from Kali. And what I'm referring to is this. So in Kali you have these workspaces, right? Well, in a headless type of server environment where you don't have the graphical user interface, you don't have that luxury. So screen is really the best thing we can do from this perspective. Okay, so something else that can be helpful is the capability to record what happened with this screen session. So you have multiple screens and maybe you're investigating a file, or you have a user perform an action and you like to collect everything that took place. Well, there's multiple ways you can do that. You can leverage the history command. So if you type in, I need to make the window active, history. The history command, it basically shows you a history of the last executed commands. We can do history, and we can append this to history.text file. If we do history text, so we saved, the history file. That's one thing. So we have a list with the executed commands. That's one auditing that we can get. And it's always, always helpful once you inherit the system to see what commands were executed and stuff like this. All the commands are located in the bash profile. So one way to view this is going to review the contents of this bash history profile. Bash history, no such file or directory, because I perhaps misplaced the period. So what I did is I went in and typed in cat and tilde / full stop bash _ history, and this is where all the commands that we've executed are located. So using the cat command, we reviewed the content, which is everything that was typed in once we executed the history command. So one way to remove this, if we use rm rf, and actually let's do this since I don't want to mess up the name of this file again. I'm gonna just hit the up arrow, and then I'm just repurposing the previous command. So rm-rf. So what this says is remove by force this bash history file. Hit enter. Now I type in history, and it still actually shows. If you go in cat and you review this file, the file says there is no such file or history. So what's going to happen is, yes, with the current session, you have the history file still shows which commands were executed. Once you log out, that's not going to be the case because this bash history file has been removed. So kind of an interesting thing to keep into perspective, just from perhaps incident response, that it can be useful. So in addition to a history command, the reason why I showed this is within screen, what we can do is we can start a transcript of everything that was outputted to the screen. So if you notice, the history command, this bash history file, is everything that you've typed in as a command, but not necessarily of the results that came out or the messages that were displayed. So the screen will basically record everything that was reflected back after you executed a command. So let's do this. Let's type in screen, get into a new screen. Then what we're going to do is Control A quick, and then Shift and H. So once you do Control A quick, release, so Control A quick, press and release, and then H, it basically shows a message that you are starting to record a file. So if we do ls, you're going to see this screen log 2 was just started, screen log 2. So screen log 2 was initiated by pressing Control A, quick release. After the release, we press Shift and H, so basically capital H. That's how we start this newly created screen log file. If you notice it, I don't have a mouse because it's a command line interface, but into the look into the top right hand corner, there's a file name called screen log period 2. Okay, so this is the one we just initiated. So now if we go in and perhaps execute a command like what is time, by the way, this is another kind of a neat command that we can use. So it gives us information. What is time? What is shadow? Shadow is an encrypted password file. Well, great. So let's stop this transcript screen log and see what content it actually captured. The way we do this, Control A, quick release, and then H. And if you notice at the bottom it says the log file screen log 2 has been closed. So this indicates that in the end of our perhaps investigation, we can go in and end this task. We can read the contents of the screen log file, and this is what happened. So it was everything that was outputted to, it's not just the command that we executed, but the output of the command. So this is the added value of this particular command. Neat thing to do, neat is to explore this command in more details, a lot of useful purposes. Enough said about screen, so let's look into another command that could be neat. So we've covered history, perhaps we can jump into the script command. Script. And oh, by the way, how to get out of a screen, so Control A K, and it allows us, do you want to kill the screen? Yes, I do. Control A K, yes, I do. Or we can simply type an exit. Screen ls, any no sockets, no screen, so all good. So what I started talking about was the script command. So you're executing a script. So the script basically makes a transcript of everything that was printed on the current terminal. It's another logging capability. It's maybe a complement or a comparative to the screen command. Really, the one that you're going to use is going to depend on your preference, but perhaps also on the availability of the command on the system. So script, what we can do is, for the benefit of the presentation, compare the output of both. So we have the screen log file. Let's create, let's do basically -A for all content, and output it to a particular file called txt. Okay, so we started this particular file that's called test.txt, and we will execute the what is history. It's a history library. What is man? Okay, it's a manual page. What is cat? Okay, what is grep? And these are just some samples, so we can fill out the terminal window with some examples that can be populated within the test.exe file. Okay, so we are finished. So what we will do is do Control D, and with Control D it says script done. Files is test.txt. Let's get the content, and this is what happened. So let's see, we've executed. So file is txt. Okay, so if you look into line 1, 2, 3, 4, 5, 6, 7, if my calculation is accurate, 8, line 8, it says root at target, colon tilde, the number sign cat text.txt. It says started script, this and this date, so it gives us a date time. And then it shows us the list command and everything else that we've executed. Okay, and it tells us, by the way, when the script was done. So this is a piece of information that perhaps was not provided into the screen log. So what we're going to do is, let's redo the screen log. Yeah, so if you notice, you don't have this thorough information with respect to the date, time, how long it took to complete it. Maybe we can do a div, and we can do test with, what was this code? Screen. So these are the differences when it comes into, that's actually not really a whole lot helpful. Or perhaps it is because the commands are different. So it shows you the differences between the two files. We really executed slightly different commands. So using the diff command, we can compare files. But because we didn't use the same command, my example really wasn't very good. So I guess we can move on with another command that can be helpful. So we leveraged script. Let's see, maybe the watch command. So let's take a look. Watch command. So what is watch? Okay, so execute a program, periodically and show the output full screen. So what we can do is we can monitor directory changes. So for example, you can monitor changes to a particular directory where the user profiles are created, or log entry is created, or you can watch really anything, and this is more like for activity monitoring. So if we use the watch command, we can initiate watch-d, then lsl. So watch listing directory. So okay, so from here we watch for any changes. Okay, maybe a better example will be to do a screen. Okay, and another screen. And then here we can do watch-d, and we can do lsl. Okay, control A0. So in this particular one, we can say make directory. We can call it test. So we made a new directory. We called it test. Okay, and then what we can do, control A0, control A1, do you see? So we leveraged the screen command, which we just practiced a minute ago. I used Control A0 on this screen to make a new directory, and Control A1 in this screen. Actually, I was watching LSL, so basically watching a listing for any changes, so anything new created, anything that showed up, and I created the directory test. So if you notice, the D for directory showed up. That's test. Control A1 is the existing screen, so Control A0 is the one before. We just made this new directory, and using the watch command, we were able to spot this. Now, we weren't necessarily monitoring the screen, but if we pay close attention to what we're monitoring, we should be able to spot the differences. So again, this is can be useful for monitoring contents of a particular file against any changes. Okay, and perhaps you have the capability to output the content. So let's move forward. We covered the logs, script history. So we're going to cross those off. Config files. Okay, so let's see which config files maybe we can look into. Okay, so maybe open SSH. I'll make sure we have it installed. So let's go into the target. So we're going to do Control C to terminate this particular instance. Exit. Exit. Okay, screen is terminated. We don't care about this particular instance. Okay, so what we can do is, let's see, we can leverage, let's have fun with some commands and kind of combining them, and show open files and search and print any result for essentially the SSHD service. Okay, so what we're going to do is list open files, and then -I for TCP, -N-P, quickly grep, and anything that matches this string. Okay, so we know that the SSHD, the daemon service, is running with this particular 4669 process ID under user root, using IPv6, the TCP protocol, and port 22 in the state listen. Okay, that was a helpful thing. Something else we can do to find out if a particular service is initiating any connections. We can do the same command, in this case grep MySQL, which in this case is using the default port 3306. Okay, so if you'd like to review the contents of the SSH client, what we can do is we can leverage the cat command, and then just refer to the location of the config file. In this case is SSH. If we're not sure, what we can do is simply go in and look up using a Google search engine, or your favorite one, DuckDuckGoose or whatever else. So we use the pipe more. We're going into the different levels. When you're dealing with SSH, one important thing to check is the permit root login option. Do you really want to permit your root account to log in to your SSH server? That's something to consider, because it could be really expanding the attack surface that you have. So all we need to do is look through these fine options. We can edit it from the current view. It's just read only. What we can do is use nano editor or perhaps vi to do that. But each of these different options have meaning. So there's usually a comment that signifies what this particular area is for, how it can be used. Let's see, so permit root login, permit empty passwords, of course not. Public authentication, permit root login, it says yes. So if you notice under the authentication section, so login up top, underneath authentication, permit root login, yes. In our case, with our target, we've already identified that it permits a root login. How bad is this? Can be very bad. So we certainly want to look into this and perhaps make some modifications. Okay, so how we do this is nano, and we go into the etc ssh shd config. So from here we can simply start going editing these permit root login. We can say no, and then what we can do is Control X. In our case, actually, we don't want to do this. We don't want to change this because it's going to break perhaps some of the environment and it will not allow you to complete some of the labs. The configuration is made on purpose to help you validate certain vulnerabilities from a different perspective. So if you'd like, what you can do is perhaps make a copy of this file. So let's back out, Control X, Control X, and then no. And maybe we can make, instead of nano, we can do copy this file into etc ssh config. And what we're going to do is we're usually going to call it .alt. So all I did is use the cp, the copy command, and I'm copying the config file to the same place. However, I'm going to call it .old, or maybe let's call it .original for the original. So if we list the contents of ssh sshd, can actually don't run this, just sshd, we can see the original there. So in case we mess up with the original, with the configuration file currently, we have the original to fall back to, and we just have to copy it over the one we messed up. We always have original. So just a security precaution before you start messing with any configuration files. So this being said, let's move on to my SQL database. So the same type of information can be revealed within the etc directory. So we're going to use the cat command, etc. In this case, we're going to go into MySQL. And what we're going to do in this case is pipe the more command. Oh, it looks like that's not the right location. I'm missing the etc MySQL, and then there should be my config file. Okay. So I do this, I do a couple steps at a time, and I look at the default port. So 3306, this is where we can go in and change the port. It looks like for where the socket is created, hit enter, some interesting areas, it tells us basic settings and so on. Again, make sure you make a copy of this file before you go in and start making modifications. Okay, so these are important configuration files and how you actually can go in and modify them. A couple other things we need to quickly cover is the location of password and user account files. So in Linux, the location of the actual user accounts is in the etc as wd directory. Okay. So in this case, what we did is we executed cat etc passwd and more. So what happens here is that we've viewed the content of accounts that are actually created. So what happens is, looking into the username, we see the actual username it was actually created, gives us the group ID, user ID, gives us the home directory, and actually the shell that's been assigned to the particular account. Something we can demonstrate here is the nature, I guess, the difference between the shadow file and the passwd file. So if we do cat etc shadow, what we can see is the actual, oh, we have a plain text password. It's not encrypted. Looking into the shadow file, the format is different. So we have a user, but then if you noticed, we have a hash. So if you're looking into here, so let's look into the user account. User colon, you have this $1 $1. What this signifies is the hash, the type of hash function that's been used to encrypt the particular password. So in this case, the $1 indicates that it's a plain MD5. If it was a $sign -5, for example, it's an indicative of SHA, the security hash algorithm, 256-bit. The letters and I guess numbers that follow the second $sign, and between the third $sign is actually the password salt, that is the actual hash, and then you have account expiration and other password change information type of fields. But it's kind of important to know what type of hash has been used, so you can kind of fine-tune your password cracking utility so you can have a successful cracking. Okay, so what else? I need to think let's find out what type of encryption is used for our passwords. The way we will do this is we're going to review the contents of the etc pamd and common password. Okay, so what happens here, it looks like we need to pipe the more command. So we're looking here, requisite pamd slug MD5, and ooh, it looks like we got excited here with the enter key. So the very last line, let's see if I can get my cursor back right here. So the passwords are encrypted with MD5. So by reviewing the contents of this PAMD file, we saw that the actual algorithm for the hashes within the shadow file is MD5. Okay. So the what is PAM? PAM is actually a pluggable authentication module, and what it does is it provides a dynamic authentication support that could be for different users, the applications, or perhaps the services that run on the system. It's essentially a neat feature, and it's basically a part of the authentication process that allows some authentication support for these applications and the ability to separate the authentication into different groups. It's easier to perhaps manage. Okay. Let's see, this was the shadow and passwd. Okay, so now networking. So if config, let's do Control-C. So in order to find out what the IP address is for the system, what interfaces are up, we're going to use the ifconfig. Ifconfig is the alternative for ipconfig in Windows. In this case, the ETH0, it's basically our network card interface. We know that the internet address is 1010.122. It's an important information to know. So if you like to bring the interface up or down, what we can do is use the ifconfig command, the name of the interface, and we can use the down. So by reviewing this ifconfig, if you notice that interface disappeared. To bring it back up, we say up, and then ifconfig, the interface is up, the same address. DH client will basically say obtain DHCP address from the DHCP server automatically. It's kind of forcing that particular command. Let's see. From a network perspective, we can also review the netstat command. Or let's see what's on the list. Yeah, netstat. Okay, so netstat. What is netstat? Print network connection, routing table, and interfaces. So netstat, it's a really neat application. ANT. It shows us basically the state. Listen for the local address, foreign address. Now, it shows us the active and established connections, and in this case, we don't have any established. We're just listening for incoming connections. If we use the same command with TULPN, what we're going to do then is get a list. It's a little bit different format. We'll get a list that also goes in to list in the state, but if you notice, the added feature is that it shows us the service along with the process ID. Okay, kind of a neat thing, and we can use that process ID to help us terminate a particular task or process from running. So in addition to the netstat command, we can also use the ss command. So I think, yes, ss command. The ss command, it's basically another network utility, and if we just execute ss, it's going to show you very similar usage to the one before. So if we do ss TP, what we'll do is it should show us actually the sockets and the processes associated with them. Let's do man-ss. Help v version enumerate all display all sockets. Okay. Processes. And the T option is TCP. Let's do this. SS. A. Okay, so it shows us all. If you use the -A option, it was basically a whole process associated. It's just different representation. An alternative to the netstat command. If we do T, anything TCP, TP, nope. T-B, nope. You can do a query process. It looks like this command is invalid. But we can use the ss-a, which again is showing the state of the connection, showing some indication of received bytes, send, the local address, the IP port, the PR address, and of course, is there any ports associated with that. Okay, so we've reviewed the ss command, list open file. So list open files. We've done some actually listing previously, but just for kicks, what we can do is we can watch network service activity in real time, the list of open files. So ls OF, and then if we execute the listen, it's basically real time listening for service activity related to network processes in real time. Really hard to do this if we are using like a more head or tail, perhaps, would be better command. Okay, so in addition to this one, what we could do is leverage command line foo. So command line foo is a really good resource for combining different commands. In the previous tutorial, I mentioned where this is and how it is associated. So it really is something that can help you become more fluent and proficient with command line.